We all think we know pain, right? It's that basic alarm system in our body. But what if that alarm gets stuck in the on position? What if I told you there's this whole secret conversation happening inside you, a conversation that explains why some pain just never seems to go away, and we're only just now learning how to listen in? Okay, let's get into it.
You know, that simple ouch, that's what scientists call physiological pain. It's a warning, and yeah, it's super useful. But what about the other kinds of pain? The kind that just hangs around long after an injury should have healed. Or, even weirder, the pain that seems to pop up for no reason at all. That's where this story gets really fascinating.
For the longest time, the thinking was pretty simple. Pain was a one-way street. An injury happens, a nerve fires, the brain says, ow, end of story. But the new story, the one we're unpacking today, is that pain is actually a neuroimmune condition. It's not a monologue. It's a dynamic, two-way conversation between your nervous system and your immune system. And trust me, this changes, well, pretty much everything.
Now, before we eavesdrop on that conversation, we need to get the basics down. Let's just quickly run through the official ways scientists classify pain. Think of it like learning the basic grammar before we can really appreciate the poetry. So science basically puts pain into three main buckets. First up, you've got nociceptive pain. That's your standard response to a harmful stimulus, like in rheumatoid arthritis. Then there's neuropathic pain, which comes from actual damage to the nervous system itself. Think diabetic neuropathy. And finally, there's the most mysterious one, nociplastic pain. This is where the whole pain system just malfunctions without any clear injury. It's a huge part of conditions like fibromyalgia. But here's the kicker. What we're discovering is a common thread that links all three of these, and that thread is the immune system.
So let's meet the cast of characters in this hidden drama, shall we? These are the immune cells that are having that secret conversation with your nerves.
First on the scene, you've got the macrophage. These guys are the body's first responders. And here's the crucial part. They're basically double agents. Depending on the signals they get, they can either pour gasoline on the inflammatory fire, making pain worse, or they can be the ones to start the healing process and actually shut the pain down.
Working right alongside them are the T cells. You can think of these as the specialists. Certain types can release chemical messengers that basically scream more pain and ramp up sensitivity. But then you've got these other types called regulatory T cells that do the complete opposite. They send out calming, anti-inflammatory signals that can really help alleviate pain.
Then we have the B cells, which are kind of like the memory keepers. We're just now learning that after a nerve gets injured, these B cells can create these long-lasting antibodies that essentially tag nerve cells, and, well, that can be a key driver in turning acute pain into chronic neuropathic pain.
And finally, the neutrophil. Now, their role is still kind of being figured out, but it looks like they're another double agent. Crazy, right? In some cases, you need them around for pain to stick around, but in other cases, an early surge of them can actually protect you from it. So just think about it. You have first responders, specialists, memory keepers, and foot soldiers all talking to your nerves at once. It's a very crowded conversation.
So yeah, it's pretty clear this is not a simple story of good guys versus bad guys. Not at all. The exact same cells can be the hero or the villain. It all just depends entirely on the context.
And, you know, this quote from the source material just nails it. The immune system doesn't just start the fire. It also has the fire extinguisher. So the million-dollar question in chronic pain is, why does the fire extinguisher sometimes fail to work?
And this slide perfectly illustrates the chemical language these cells are using. On one side, you have pro-inflammatory molecules like TNF-alpha that are essentially shouting pain at your nerves. But on the other, you have anti-inflammatory signals like interleukin-10 and, get this, even opioid peptides. Yep, your own body makes them. And they're whispering, it's okay, calm down. The balance between these two sets of signals is what determines everything you feel.
So we know who is talking, but how does this conversation actually work? How do these immune signals literally change what a nerve is broadcasting? Let's zoom in a little closer and see how they turn up the volume.
Okay, so here's our baseline. You have a nerve pathway, right? It runs from your peripheral tissue, let's say your skin, all the way to your spinal cord, and then it goes up to your brain. This is just the wire that's carrying the signal. Now watch what happens when the immune cells join the party. They release those pro-inflammatory messengers we just talked about. These molecules act directly on the nerve, lowering the amount of stimulation it needs to fire. It's exactly like turning up the volume on a microphone. The nerve becomes hyperexcitable. This process is called sensitization, and it's the very reason why a gentle touch can feel agonizing after an injury.
But remember, this conversation goes both ways. Other immune cells, or even the same cells that just switch teams, can release those anti-inflammatory signals. They send out molecules like IL-10 or those natural opioids, and they do the exact opposite. They raise the nerve's firing threshold. They actively turn the volume down, resolving the pain and helping things get back to normal.
So this new understanding isn't just some fascinating biology. It's a complete game changer. It's a brand new roadmap for how we approach and treat chronic pain. And it finally explains why just trying to block a nerve signal often isn't enough.
So the new frontier is all about modulating this neuroimmune conversation itself. Instead of just blocking the signal, we're looking at therapies that can interrupt the inflammatory messages, like JAK inhibitors. We're exploring ways to calm the entire system down with things like vagus nerve stimulation. We're even discovering how changing your gut bacteria can shift the immune environment, or how using tiny doses of certain molecules can boost our body's own team of pain-resolving cells.
The shift in thinking here is profound. The goal is no longer just to find the mute button for the alarm. It's to become the moderator of the conversation, to encourage the signals of resolution and healing, and to quiet the signals of that persistent pathological pain.
And this leaves us with a truly fascinating question, doesn't it? We just learned about this incredibly intricate dialogue between our immune cells and our nerves. So it kind of makes you wonder, what other secret conversations is your body having, right under our noses, that we're only just beginning to learn how to listen to?